Unit Operation Classroom. This is the website. My name is Shekhar Bhattacharjee, and today we are discussing extractive distillation component identification. A binary mixture of butane and butadiene, let's call this as B and let's call this as D, is to be separated in an extractive distillation system using furfural. This is called a solvent or entrainer. We'll look into that. Uh, so, what is the role of furfural in this mixture, butane and butadiene? Furfural lowers the activity of butadiene more than it does for butane. So, consider the distillation sequence. So, this is an extractive distillation sequence. So, to understand that, first we'll understand a little bit about butane and butadiene, why they are difficult to separate. Then, why do you have to go for extractive distillation? So, what is the thermodynamics? What are the thermodynamic concepts behind the extractive distillation? And we will see. Then we will come and address this problem. In this problem, it says there's X and Y and Z. Of course, this is butane, butadiene, and furfural. All three of them come into the column. And component X comes out from the top, which is nearly pure, and therefore, of course, Y and Z comes out from the bottom. And then, of course, this is another distillation column 2, where Y comes out as nearly pure, and this Z, of course, comes out nearly pure. The problem is to find out which one out of this X, Y, and Z, which one is butane, which one is butadiene, and which one is furfural. So now let us quickly understand what are the boiling points, why they are difficult to butane and butadiene system, what is so unique about it. They have almost similar boiling points. So these are the normal boiling points. As you can see, there's a 4 degrees Celsius difference, which is insufficient for a proper separation by standard distillation methods. And if you look at the relative volatility, which is defined as this is almost equal to 1 because of very close boiling point, and of course nearly close vapor pressure at the same temperature. So it is very difficult to separate butane and butadiene by standard distillation methods. So we go to extractive distillation. So what happens? What are the basic brief concepts about this extractive distillation process? Um, as we say, this is the relative volatility between butane and butadiene. And we know for each of these components, so for butane, so we assume the gas phase to be ideal, and of course the liquid phase to be non-ideal. We are writing in terms of the liquid phase mole fraction and the activity coefficient and the corresponding vapor pressure. And the same thing for butadiene. Okay. What is activity? So B is for butane and D is for butadiene. What is activity? We know conceptually, approximately activity is a relative tendency to escape in the vapor phase. If you have a liquid vapor mixture, so you can say activity is, of course, a relative tendency to escape in the vapor phase, or inversely, it's relative tendency to remain in the liquid phase, if we look at the inversely. And this, of course, Xi gamma is, of course, activity. Okay, so what happens? Butane has weak interaction between butane and furfural. When we add the furfural to a butadiene mixture, so what happens? Furfural has a very weak interaction, whereas it's a very stronger interaction with butadiene. Okay, so it has a stronger compared to butane interaction with butadiene and furfural. So what is the effect of that? That is, of course, already given in the question. It says furfural lowers the activity of butadiene more than it does for butane. Okay. So if that is the case, so the activity of butane would be higher than the activity of butadiene. That is according, it's all the information given in the problem. So if we just define the relative volatility in this method, so we can say numerator would be, so these two are almost identical. The vapor pressures are almost identical because the boiling points are almost similar. So this would be much higher compared to this one. So what happens if this is much lower? As you can see, by adding furfural, the relative volatility tremendously jumps much higher than 1. So therefore, the separation between butadiene and butadiene becomes very easy. So of course, since the interaction between butane and butadiene, activity of furfural lowers the activity of butadiene much more than it butane. So if it lowers the activity of butadiene, so that means what happens, that it has butadiene will tend to stay in the liquid phase much more than the butane. Okay. So what happens if you have a butadiene mixture, if you add furfural to it, since this has a much stronger interaction between the two, so it reduces its activity coefficient much more than it does to butane. So what happens, butane has a higher tendency to escape in the vapor phase, and butadiene has a higher tendency to stay in the liquid phase. Well, as we understand, that is the basic concept of the extractive distillation. So if we understand that, so if we have butane, butadiene, and furfural coming into it, so the moment we add furfural to the system, of course, the butadiene will tend to more on the bottom, at the bottom, and butane will tend to be on the top in the vapor phase. So this excess is to be equal to butane. So once this is going here, so this is a mixture of, so this is nearly pure. So this is basically butadiene and furfural. Okay. So once this goes here, of course, there's a tremendous difference of boiling point between butadiene and furfural. This is negative 4.5. This is 162. So this is a standard, very simple distillation column, where of course butadiene will come from here and furfural will come from here. So in this XYZ mixture, this should be X would be equal to butane, and Y would be equal to butadiene, and Z would be equal to furfural. So X would be butane, and Y would be butadiene, and Z would be furfural. So as we can see, P is equal to 1, Q is equal to 2, and R is equal to 3. So A is the correct option. Okay. All right. Now let's quickly look, just like other problems, what are the applications of this one? Process industry application of this problem. Butadiene extraction. To purify 1,3-butadiene from C4 streams, which normally contains butane, butenes, butadienes, etc. 1,3-butadiene, of course, is a very important industrial product because it's used for rubber manufacturing. We know that. So we add furfural, basically called a solvent, or it's called an entrainer also. So this is a popular solvent or entrainer for separation of butane from butadiene, and has had tremendous application in process industry. Aromatic extraction, benzene, toluene, xylene from paraffins and naphthalene, again in deformed gasoline. DMSO, dimethyl sulfoxide, is the solvent or entrainer. In ethanol dehydration, to break the ethanol water azeotrope with a maximum boiling point, so basically minimum boiling point. So this is a minimum boiling azeotrope to produce pure anhydrous ethanol, which is used for blending. So this has a tremendous application these days in these fossil fuel problems. Ethylene glycol is a solvent particularly used. So this extractive distillation is a tremendous application in our chemical process industries. So again, this is the A is the correct option.